Hello, my name is Dejanay. I am a math major and education minor at Rowan University. My objective for today is to present both the traditional methods of teaching mathematics and the non-traditional methods while examining the consequences on mathematical learning. So mathematics was defined by Isaac Newton and René Descartes as a tool to organize, communicate, and convince others of their hypothesis, while Paul Lockhart, a mathematics instructor, and author of Lockhart's Layment, defined mathematics as the art of explanation. Now, let us look at the history of mathematics education. Um, in the 1960s, mathematics was looked at as the modern math era. It highlighted an emphasis on the precision and rigor, followed by a process driven, hands on approach to teaching and learning. The development of mathematics and the hands on approach continued in the 1970s. Uh, Dr. Susan Nesmith, an associate professor of STEM education at Baylor University, labeled this era as the laboratory mathematics period. The era consisted of the increased development of technology and the mentality of equal education opportunity. Later in the 1980s, the focus of education shifted from a back to the basics mathematical reform to more one of critical thinking. The National Council of Teachers of Mathematics worked on creating a reform of mathematics education that would make critical thinking a priority. Move on to looking into our first method, which will be the traditional method of teaching. This method consists of primarily objectives of the teacher being the main focal point in the classroom. The teacher is then responsible for all the actions and guaranteeing that all the classroom messages go through them. Once all of the information is given, the teacher gives examples for the students to complete on their own. Generally, the requirements in this form of classroom is for the students to memorize the material and be able to regurgitate it on exams or homework. Here's where we take a transition and look more deeply into how a classroom and a lesson would be taught in a more traditional method.
Here we have a quadratic equation that we need to solve for x, and we're going to use the quadratic formula to solve it. When you look at the quadratic formula, the important thing to notice is that your quadratic equation must be in standard form. It has to have the x squared term first, then the x term, then the constant, and it has to be equal to 0. You can't use it if it doesn't have a 0 here at the end. So in our case, we have a 20 at the end. That doesn't mean we can't solve it. It just means we have to subtract 20 from both sides first. Now that we've subtracted 20 from both sides, this is in standard form. So now we can identify our values of a, b, and c. A is always the value of the coefficient in front of the x squared term. In this case, there's really a 1 here. The b value is the coefficient of the x term, so we have a positive 8. And c is the value of the constant at the end. So since we have a minus 20, that means our c is negative 20. After you've figured out a, b, and c, you want to plug those values into the quadratic formula next. The formula has a negative b here. That's really a negative 1 times the value of b. And anytime you multiply a number by negative 1, it's going to change the sign. So always think of it as the opposite of b. B squared is 64, and then we have minus 4 times the a value times c. I usually put these in parentheses so that I don't miss a negative sign. Now this entire thing is divided by the value of 2 times a. After you've plugged your values in, you want to start doing some simplifying. And I usually start with what's under the square root here first. And I start with this part, the minus 4ac. Treat this 4 as a negative 4, so it's really negative 4 times 1 times negative 20. So under the square root, really, we have a 64 plus 80. 64 plus 80 is 144, and I know the square root of 144 is 12. So this whole expression under the square root, this comes out to a 12, so I can rewrite it now. So instead of saying plus or minus this whole part, I can just put a 12 there. And then I know 2 times 1 is just 2. Once you get to this part where you've simplified the square root, you're going to split it up into two separate answers. So we're going to write it out once with a positive sign and once with a negative sign. You're going to simplify the numerators next. Negative 8 plus 12 is 4. And always divide last. 4 divided by 2 is 2. So one of our answers is 2. X equals 2. To find the second answer, use the subtraction one. Negative 8 minus 12 is negative 20. Negative 20 divided by 2 is negative 10. So that means our second answer is negative 10.
Back in elementary school, that's generally how they taught us in most subjects and not just mathematics. And so just looking deeply or a little bit more uh, deeper into the effectiveness of that method that we are used to learning. Studies have shown that the traditional method was effective in some ways. We have pros of, lots of information or material being able to be covered during a smaller amount of time, um, and less disruption. The teacher had what seemed to be a bigger impact or bigger control over the classroom and in disruptions and um, things of that sort. But the cons that kept coming up, along with the complaints of the students stating that they didn't understand the material, or some of those who stated that they didn't like math or things of that sort. Um, Cons are more so that the students are passive learners. They're not active in the learning at all. A lot of material is being missed or forgotten because they're just sitting there and paying attention and not really being active and truly understanding the material. The information is being memorized and not. Now we're going to transition over into some of the non-traditional methods that will be discussed for today. Um, the first one is going to be the discovery learning method. Here, the students are to be guided into exploring and discovering. The teacher's responsibility is to refrain from pouring the information into the students' minds, but rather be the guide throughout the student's discovery. And second is going to be the problem solving method. Here, it's said to be based on the cognitivism learning theory, which is a significant element in mathematics. The National Council of Teachers of Mathematics emphasized that mathematics teachers focus on this method because it embodies skills that are important for everyday life. The skills obtained through the utilization of this method helps people to adapt to unforeseen changes or problems in their lives. And the last method that we'll be discussing is going to be the inquiry-based learning method. In a similar fashion to some of the other non-traditional methods in the two that we've previously mentioned, the teacher is to use this method to encourage and aid students in thinking and communicating their mathematical thinking. The communication of this method is done in an uncustomary manner. Students are to express their thought process. We're going to take a closer look at our first untraditional method of teaching. It's going to be our discovery method. Here, Lockhart, who we've previously discussed before and earlier in the presentation, had 5 steps that he felt that the teachers or instructors needed to apply for the discovery method to be efficient. The first step is for teachers to study, research, and primarily study their students and use the natural problems that are constructed for them. The second step is to give the students time to make discoveries and to formulate conjectures. Step 3 is that teachers need to help their students refine their arguments and create an atmosphere of healthy, vibrant mathematical criticism. 4 is that the teachers need to be flexible and open to sudden changes in direction. And the 5th is that teachers should have an honest intellectual relationship with their students. And the second non-traditional method that we will be discussing is the problem-solving method. Here, there are 4 steps that the teacher needs to established within our classroom in order for this method to be effective. The first step is to make sure one has an understanding of the problems. To help students during this step, the teacher would ask questions like, what is known or unknown? Is there enough information or more information needed? What do the terms mean? Step two is to devise a plan. Here, students should explore ways to solve the problem. There are several strategies that can be used, like drawing pictures, using variables, and choosing helpful names for those variables. They can use a guessing and checking method, also, or looking for patterns, and lastly, making a list. Step three is to carry out the plan. Students should start with the plan. Once the problem is started and students notice that it's not working, then they should start over and try a different approach. It is very important for the teacher to make the student aware that during this step that there is still something to learn when an approach does not work with the first at first. It just helps eliminate the approach and ultimately gets them closer to the one that does work. And then the last step is to look back. Our third technique that we're going to be looking at under the non-traditional methods is the inquiry-based learning. Uh, Also, this has four strategies that they want to pinpoint. The first strategy is to establish the purpose for writing. The teacher or instructor would need to ensure that the students were aware that the basic reason for writing would be to support their learning and to help them help the teacher assist with that progress. The second strategy is for the teacher to establish themselves as the audience. This step is extremely vital because it lets the students know that their writing will help provide insight of their understanding. The next step is to make sure that the students are as detailed and thorough as possible when explaining their thoughts throughout the writing. And then the last step is to discuss ideas before writing for those who have difficulty. On this slide, we'll be discussing some examples of how each method can be used within a lesson. The first is the discovery method. Here, the teacher provided a space and opportunity for the students to participate in class activities to reflect on during group discussions. She made sure to pay attention to the students as they gave their ideas so that she would be able to help clarify and allow for them to find the problems. The example she wrote on the board is here: x over y equals 7 over 2 and x plus y equals 63. The answers were x equals 7 and y equals 2, and the result was x plus 7 equals 9. The teacher then posed this question to the students. She asked the students what they noticed, and it was discovered that there is another function, which is x plus y equals 63. Therefore, x does not equal 7 and y does not equal 2 because x plus 7 does not equal 63. Students, we need to solve for two equations and two unknowns here. Moving on to our next method, the problem solving. The teacher in this lesson presented three problems for two reasons. She wanted to teach the students fractions and also equations. While the students were working on the exercise, the teacher asked the students what they noted about the equations. She began by asking them what the difference was between y minus 6 and 6 minus y. She also asked the students what would happen if the original equation looked like y minus 6 over 3 equals y minus 6 over 2. And our last method and example of that would be in the inquiry-based learning method. The teacher began the lesson here with specific questions. Here we see she asks, what is a fraction? The teacher then draws 7 equivalent squares on the chalkboard. Following, the teacher proceeded to ask the students to show her 7/14 of the squares. During this portion of the lesson, the teacher left the challenge up to the students. She did not provide the students with any formulas or strategies. She asked students thought-provoking questions throughout the lesson, which enabled her to guide the students into a sense of understanding and more specifically the meaning of 7/14. In the reform of math, education has taken years to get to this point. The reform of any subject requires a lot of time, effort, and money, of course. But ultimately, the knowledge and discovery that will be obtained through the process provides the students with a new and adaptive mindset that can be used for years in many scenarios outside of mathematics. The overall focus is to increase the effectiveness of teaching and thus learning for the students in years to come.